Okay, in this video, what we're going to do is the inverse normal distribution. So the way this one works is the following way. There are occasions when we're told a proportion of the data. So basically, you're given the area under the curve, which is the probability, let's say. And we are to consider and ask questions about the data conditions that are appropriate for those portions. So you might be given that, like I said, the area under the curve, which you then might find a particular value that you're interested in, or like let's say the x value or the standard deviation. Two examples that we're going to see. So let's consider this population of crabs, where the length of shell xm, x millimeters, is normally distributed by a mean of 70 millimeters and a standard deviation of 10 millimeters. A biologist wants to protect population by allowing only the largest 5% of crabs to be harvested. Right, so the largest 5%. The idea here is this. The largest 5%. There's the largest 5%, let's say, right? That's our idea here. The crabs to be harvested, therefore asks the question 95%. Notice he says 95% of the crabs have less than what? Right? So it's that K value. What is that K value there? So it's less than this K value, right? So you can use this on an inverse, something called an inverse normal that's on your GDC. So the GDC can do this. So here's an example. And I'll show you, I'll bring in the calculator, which I have right here. And I'll just show you how to do that. So what we have here is a university professor determines no more than 80% of his of this year's history candidates should pass the final exam. Mean is 62 and standard deviation is 13. Great. So we are going to say the following. The whole idea is this. I'll draw a little picture to make sense of it. There's our distribution. You know you have a mean of 62. There's a K value where you know 80% need to pass. So this is below this. So right here, that's your 20% failure. This is everybody here this is your 80%, right? Need to pass. So then what is this K value? We need to find that. Well, if you go into your normal, so the distribution is then second distribution. And you go down to inverse norm. There it is, inverse norm. And I'm going to go enter. And notice what I have. There's the center, right. This is talking about, if I move this, I should be able to move it. Yeah, there it is. This would be your center, right here, like right here. This is your left. This could be your center. And then this would be your right, right? So this is the idea. So this could be demoted. This is left. Maybe here to here, center, something like this, and then right. So that's the idea that we're doing. So the area, we know the area under that is that red one, so it's going to be 0.2, enter. The thing, our mean is 62, enter. Standard deviation, 13, and I'm going to keep it to the left. Enter, enter. There it is, 51. So that's what 51.06, let's say. So this is going to be, so I put in inverse norm. This is going to be 0.2, comma. This was, what was it? 0.2, 62, 13, And then I think, what was the last number? Left. Right? So I'll just put L for left. So that came about to approximately 51.05989, which implies K would equal to 52. You're in the 52nd one. So that's how you'd be able to find it. So you know K now is 52. The next one, what we can say is, again, we're doing with this X, which is approximate to a normal distribution, 8 sigma. That's my variance, right? But this time we're asked, in this case, what is the value of the standard deviation? Oh, a little bit more of a tricksy thing. Notice the chance of the tube probability last 5 years is 0.5%. Now, when they say 0.5%, 0.05%, this is a probability. Now, the thing here is key. Think Z-score. Because in the table, in using tables, this is the only one you would get. You would never use the 8, right? The standard deviation or the mean like that as a particular value. It would always be this. So really think about that when you're doing these types of problems. It's only going to be your mean is 0 and your standard deviation or variance would still be 1, right? But your standard deviation here, this is what we'd look at, it'd be 1. So that's what you need to consider. So you actually would need to put this into the mean into a Z-score. So what we would have is X is less than 5, right? So we'd have less than 5 years. Last year will not last 5 years, so less than 5 years, which is the probability of 0.05. Well, that means this. If I convert it to my Z-score, this is going to be Z less than, well, it's going to be 5 minus 8 divided by sigma. This is equal to P of Z less than minus 3 sigma, right? Well, here's the thing. What you can do is it'll be equivalent. It is equivalent, you can say. This is going to be equivalent, right? It is equivalent to say that this minus this, right? So this, it's equivalent to say that minus 3 over sigma is equivalent or equal to 0.05, right? It is equivalent. Then this allows you to solve for your standard deviation. Now we can find sigma. Therefore, sigma is equal to sorry, it's not that. It's not your, put in your inverse. So if you put in your inverse, so inverse normal of I believe it's, what did I calculate? Yeah. 0.05, and it's going to be your mean is 0, 1, because you need to have that, and left. That then is approximate to minus 1.6449. So this is going to be minus 1.6449. Therefore, minus 3 divided by minus 1.6449. Sigma then is equal to 1.8238, meaning it will last 1 year and 10 months. There you go. That's how you'd be able to do that. Okay? But that's the sort of thing where there is an equivalence where we can say the probability of this is equivalent to saying the inverse norm distribution of this is minus 3 over sigma is equal to that minus 1 point whatever, right? So, but you do need to put it into the standard normal. So this is need to put it into the standard normal. That's what you need to do, and that's this guy. Okay, so that's it. That is a wrap on the course.